In this video, I'm going to introduce you to logarithms. Now, logarithms get a bad rap because of a couple of things. So if I gave you this logarithm here, log base 2 of 8, it looks kind of complicated. In fact, the notation log is quite different than anything we've had before. So we're going to go ahead and talk about, I'm going to introduce you to logs, but you're going to find that they're really not so bad if you understand what a logarithm means. And there's a couple of things that are really key if you're going to master logarithms. And I find that for a lot of students, if they get these basic ideas down, they'll do very well with logarithms. So let's get started. So first of all, let's complete the table here. Here we're writing down some powers of 2 and powers of 4. Of course, 2 squared is 4. 2 to the first power is 2. Anything to the 0 power we've learned in the past is 1. And 2 to the negative 1 power, remember we have a property a to the minus n power is 1 over a to the positive n power. So that's what we're using here. Here this would be 1 over 2 to the first power, which is just 1/2. And 2 to the negative 2 power would be 1 over 2 squared, or 1/4. In fact, notice the pattern here. 2 to the first power is 2, and 2 to the negative 1 power is 1/2. 2 squared is 4, and 2 to the negative 2 power is 1/4. So I always say that negative exponents lead to reciprocals. We're going to go ahead and fill in number 2 here, not negative numbers. So notice 2 to the negative 1, 2 to the negative 2 power, these are both going to give us positive answers. So we've got to remember that we end up with a reciprocal, not a negative number. But again, we've got a pattern here. We know 2 cubed is 8, so 2 to the negative 3 power would be 1/8. So you can go ahead and fill out the next column and then check your answers. All right, so let's see. This is 64. 4 squared is 16. 4 to the first power is 4. Again, 4 to the 0 power is 1. And since 4 to the first power is 4, we know 4 to the negative 1 power will be the reciprocal of that, 1/4. 4 squared is 16, so this 4 to the negative 2 will be 1/16. And 4 cubed is 64, so we know that 4 to the negative 3 power will be 1 over 64. All right, so let's move down to number 3 here. It says in the exponential statement 2 cubed equals 8. The 2 is called the base. The 3 is, of course, called the exponent. And we sometimes call the 8 the power. I'm going to keep it real simple here, and we're just going to call it the answer. Really sophisticated here. All right, let's move on. So we're going to kind of do a little workout with our exponents. Let's see how well you know your exponents here. So it says on A here, what exponent do you put on a 3 to get an answer of 9? And over here you can see that's basically what we're looking at. What exponent do we put on a 3 to get 9? Well, we know 3 squared is 9, so the answer here is 2. What exponent do you put on a 5 to get an answer of 125? Well, that would be 3, because 5 to the third power is 125. What exponent do you put on a 9 to get an answer of 1? And that'd have to be 0. Anything to the 0 power is 1. And then finally on letter D, what exponent do you put on a 5 to get an answer of 1/25? Well, we know 5 squared is 25. So 5 to the negative 2 power would be 1/25. All right, we're going to move down to number 5. So you may want to go ahead and solve these and do what you can, and then check the answers that I give. All right, so on 5a, 10 to the what power is 100, that would be 2. 3 to the what power is 27, x would have to be 3. So you can see that we're just doing something similar to what we were just doing in number 4. On letter C, 5 to the 1 power would be 5, so x is 1 here. On letter D, 6 to some power equals 1, that would have to be 0. Letter E, we know 6 to the first power is 6, so 6 to the negative 1 power would give us 1/6. In letter F, we know 3 squared is 9, so 3 to the negative 2 power would be 1/9, so x must be negative 2. Now G is a little bit more difficult. It's not going to be a negative exponent that's going to work for us here. 3 is not a fraction, for one. It's not a reciprocal. And we know 9 to the 0 power is 1, 9 to the 1 power is 9. So we have to think a little bit harder. And something we learned in the past was that if you have something to the 1/2 power, that's equal to the square root of that base. And in fact, that'll work here because the square root of 9 is 3. So 9 to the 1/2 power would be 3. So x is 1/2 here. Now if you look at h, 2 to the some power equals 5. Well, we know 2 squared is 4, and 2 to the first is 2. And if we take the square root of 2, that's not going to help us here. We don't really have anything here. In fact, we don't really have an opposite for taking 2 to a power. So I'm going to go ahead and say that x is the exponent you put on a 2 to get an answer of 5. Not very impressive here. That's about the best we can do, but we're going to do better real soon here. So the first thing I want you to understand, if you're going to be successful in working with logarithms, you got to know your exponents pretty well. You got to be able to do problems like the ones that we just did up to number 5. So it all starts there. All right, let's move on. So it says, consider the last problem, 2 to the x power equals 5. The question here is, what exponent do you put on a 2 to get an answer of 5? There's certainly no integer that works. How do we solve this equation for x? In fact, we have no way to do this without a new function. This new function is the opposite of the exponential function. So that's the key here. The opposite of the exponential function. And this is what we call the logarithmic function. Whoops, hold on a sec. And this is how we define it. The function y equals the log base b of x is the logarithmic function with base b, where b is greater than 0 and b does not equal 1. So just as it was true with exponential functions, our base is positive and it can't be 1. The big thing here is this definition that we have right here. And in fact, this is the second thing that you need to master if you're going to be successful with logarithms. So let's go ahead and talk about the 3 parts that you find in each one of these statements. So if you look to the right, b to the y equals x is what we call exponential form. And we have 3 parts here. Of course, b is the base, y is the exponent, and x is what I was calling the answer. Now in the other form, the letters represent the same things. So notice b is the little subscript there. I call it the little guy. But it is a subscript. It's low and a little bit small. And then notice the y, the exponent, is all by itself. I call it the loner term. And x would be the answer. So you've got to get to know these 3 parts, and you got to be able to go back and forth between these 2 forms. So look down at the examples here. On letter I, it says log base 2 of 8 equals 3, means 2 cubed equals 8. Well, again, 2 is, oops, I'm sorry, I want to star that statement up above. That's the one that I want you to know really well. I want you to know your three parts. Now let's go ahead and look at the example here. So 2 is the base here, 3 is the exponent, and the answer is 8. And so our base in the logarithmic form is the little guy. The 3 is my exponent, that's the loner term, or the one that's all alone. And my answer is the 8. And so in logarithmic form, those are the three parts. So if you look at number 2 here, we have 3 is the base, 2 is the exponent, and 9 is the answer. So in log form, you have 3 is the base, and I actually like to do this. 3 is the base, 2 is the exponent, and 9 is the answer, or 3 squared equals 9. So that's how I go in reverse when I have something in log form. Let's look at the last statement here. Notice 4 to the negative 2 power is equal to 1/16, and that's what we have over here when it's in exponential form. Alright, so let's do some problems. So it says write each equation in exponential form. So in number 6 here, my base is the little guy, the 5. The 3 is my exponent, and the answer is 125. So again, it's 5 to the 3rd power equals 125. On number 7, it'll be 3 squared equals x. Go ahead and try 8 and 9, and then you can check your work. All right, so on number 8, 10 to the negative 2 power is going to equal 100th. So we could go, oops, let me go backwards here. So we could do this. Basically, our base of 10 to the negative 2 power equals 100th. That's how I check myself, or go from logarithmic form to exponential form. So on number 9, you should have a base of e to the 1st power equals x. Let's look at number 10. Now we're going from, it says write each equation in logarithmic form. So these are all exponential equations. So let's go ahead and write the word log. Our base is the 3. That's going to be our little guy. And the exponent goes all by itself. And the answer is 81. So it's log base 3 of 81 equals 4. Number 11. Let's see, I would write log first. My base is 9, so that's my little guy. The exponent goes all by itself, and the answer goes right there. So go ahead and try 12 and 13, and then you can, so stop the video, and then you can watch the video. All right, so on number 12, it's the log base 5 of 1/5 equals negative 1. And remember, number 13, that's actually the problem that we were doing earlier, the one that we couldn't do because we didn't know of a power that we could put on a base of 2 that would give us 5. Well, by changing to log form, we actually solved this for x. Remember I said that the exponential function and the logarithmic function are opposites of each other, or inverses of each other. So in this case, you have the log base 2 of 5 equals x. So we know what x is. Of course, we're going to have to do a little work to actually know what number that is, but at least we've solved for x. All right. So if you look at number 14, it says evaluate without the use of a calculator. Now a logarithm essentially represents an exponent. So if you look at number 14, it's the exponent you put on a base of 10 to get an answer of 100. Well, 10 squared would be 100, and so we get 2. On number 15, this is an exponent. Again, a logarithm represents an exponent. It's the exponent that you put on a base of 2 to get 1/4. Well, we know 2 squared is 4, so it would have to be 2 to the negative 2 power. So this is equal to negative 2. All right, let's look at, so you can see that what we're doing when we evaluate these logs is what we were doing when we first started this lesson in those first few problems. It's the same thing, just a matter of knowing how to interpret the logarithm. So on numbers 16 and 17, again, you should try those and then check the video. All right, so let's see. You have that you need to, let's see, this exponent is the exponent you put on a 4, a base of 4 to get 64. Well, 4 cubed is 64, so this logarithm is equal to 3. Number 17, what exponent do you put on a base of 5 to get 5? Well, that would be 1. All right, let's move on. On number 18, what exponent do you put on a base of 3 to get 1? That would be 0. Whoops, got ahead of myself there. On number 19, what exponent do you put on a base of 9 to get 3? Well, we saw earlier that 9 to the 1/2 power would be the square root of 9, which does give us 3. So here the exponent would be a half. And, I'm going to show you something here. You could actually say this equals x. Let's say you're having a hard time figuring out what this means. Well, we could write this in exponential form. It would be 9 to the x power is equal to 3. And so now you can see, as long as you know your rules of your exponents, then you could figure out what this would equal. All right, so in a similar way, we could solve number 20. Let's go ahead and, first of all, a square root of 5, we could write that as log base 5 of 5 to the 1/2 power. So here the question is, what exponent do you put on a base of 5 to get 5 to the 1/2 power? Well, that's just going to be a half. Now, for some people, it's like almost too easy, it gets confusing. So you could do kind of like what I did in number 19. You could say the log base 5 of 5 to the 1/2 power equals x. And now let's change to exponential form. So our base is 5, our exponent is x, and our answer is 5 to the 1/2 power. And so since we have the same base, it must be true that x equals a half here. So that's another way you can work a problem like number 20, or anytime you're having a hard time figuring out or evaluating a logarithmic expression like these. All right, let's talk about common and natural logarithms. So it says that the log of x means the log base 10 of x. Another way to say that is the common log of x is log base 10 of x. So if we don't write the base, it's understood to be 10. On natural logs, ln of x means the log base e of x. It turns out when you're working with logarithms that a base of e is a really convenient base to work with. And in fact, if you look on calculators, they normally have an ln button and an log button, and that's for these two logarithms, because they're so common. All right, so let's go ahead and do number 21. It says write each equation in exponential form. So we know our base, whoops, I didn't finish that up above. So we know here our base is 10. And so if it helps, you can write that in there like I did. And let's just change this to exponential form. Our base is 10, the exponent is 2, and the answer is 100. Again, you can do like I did earlier, 10 to the second power equals 100. On number 22, our base is e. Remember, a natural log, an ln, represents log base e. So our base here is e. You could write it in like I did there. And now if we go in, if we go to exponential form, it'll be e to the first power is equal to e. And that's what we have here. And that's true. E to the first power does equal e. On number 23, now we're going to go the opposite way and change to logarithmic form. So this is a log base 10, and our exponent's -1, and so the 1/10 goes right there. Now we don't normally write the 10, so this would be written as the log of 1/10 equals -1. Let's look at number 24. This is log base e, our base is e here, and the exponent is 0, and so that makes the 1 the answer. All right, let's move on. Oh, I'm sorry. We want to make sure we write that as natural log of 1 equals 0. That's what ln means, is log base e. All right, we're going to go ahead and stop this video here, and then I'll do a second part.